Now, since I will be talking about how to solve a problem, by problem means you have a problem, you have a given problem in probability or mathematics, that's the entrance. How to approach a problem. That is something you need to learn, and that should be scalable enough to any aspect of life, any problem, whether it's academic problem or life problem. You should approach it in that manner. You break down the problem into easier portions, which is called a divide and conquer policy. The point is, you divide the problem in simpler problems or smaller aspect, and then try to solve those, and then combine that to solve the entire problem. And for that, you need to have a clear understanding of what is the information given in the entire problem.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine.
So this is IIT JAM MS 2024, problem number 21. So you have this random variable x. Understand this bit in details. You have this random variable x. It's given to random variable already. So, but then an extra condition is given that it's x and minus x has the same distribution. Question is that what does it mean by it? Like, this is an unique condition, right? So what does it mean to have x and minus x with this from the same distribution? Yes, and every student is encouraged to share their insights into the comment box so that there's an equilibrium and balance maintained. So now the next information that is given is y is equal to x squared is a continuous random variable with the given probability density function. So this is nothing but the distribution of y. So y is following this. So there are three pairs of information. So it's a triplet of information that you need to find. You are given a random variable x and property of x. So understand this very carefully. And you're given a random variable y with the property that if the whole y follows a certain distribution that is given g of y, but also the relationship between them is given by y is equal to x squared. So therefore, you can translate the distribution of y, the idea of y, to go into the distribution of x, right? That's a natural understanding, right? And you can understand, therefore, the problem is asking. So it's a natural question that y is given. Nobody will ask you to find the expectation of y, right? So naturally, the question is given. Find the expectation of x minus 1 whole to the power 4. You have to translate the information of y distribution to x and make sure that you find the following expression, which is nothing but a property of the distribution of property of x, right? So you are given information about x with this symmetric, whatever x is same as minus x. Y is following a given distribution and the relationship of y and x. And actually, they're asking you to find the expected value, which is a property of the random variable x. So natural question is, so how do we find this expectation of x minus 1 whole to the power 4? Translating from x. So how do you find expectation? So the first natural question is, how do you find expectation? So you find expectation in if you know the distribution of x, let's say normal mu comma 1, then you define expectation of x as minus infinity to infinity x and then f of x dx, and then you find it. Simple, right? This is quite interesting. This is and next I will say it's called Lotus, the law of the unconscious statistician. What does it? It tells you that even if without finding distribution, you can find it. How? So if x follows some distribution, normal mu comma 1 or whatever, let's say f of x, then expectation of any quantity, any function of gx is nothing but integration minus infinity to infinity. You don't have to find the new gx distribution. So this is the gx here, right? You don't need to find it. Why? And that's what the law of unconscious statistician is, that even if the statistician just replaces x by gx, then also it will hold, because let's say he or she considers that it's, let's say, some x dash, and then replace x by x dash. So the statistician sees that x is replaced. If x is here, what will be x dash? Person replaces x by x dash and therefore replaces x by gx. Then also it holds. And this is therefore called the law of the unconscious statistician. So therefore, we can just find the expectation without finding the distribution of this too, but we do not know what is needed. The problem will say what is needed. The information will say, right? We will see what is needed. But these are two main ways to understand, to get an idea about how to find an expectation. So we know the arsenal needed to find the expected value. But now the question is understanding the relationship, like discovering the property, the distribution, or the behavior of x from the relationship where y and x and the y distribution. This is where we are going to head towards. You see, so this happens in the mind of a problem solver very quickly, but we are slowing it down so that you understand at a considerable rate, step by step manner. The goal is what? The question, the new goal is to find out any information about x or expectation of x or expectation of x minus 1 whole to the 4. Any one of them. We want any one of them, right? If we get any one of them, of course we can get the other one, the final result from the relationship of y and x and the y distribution. This from these two information we want to find it. So let's try it out. Now the goal comes to discover these two properties, to understand what this two property means. So the first property is, so therefore this boils down to understanding what does it mean by x is the same distribution of x minus x, and what does it mean that y having, so what does it mean that y having this certain distribution and y is equal to x squared. What do these two information mean together, rather mean about x? That's what we are interested in. We want this and both of this to understand x. So let's see that what does it mean. X and minus x has the same distribution, right? So let's do it from the very beginning. Understand that if x and minus x is the same distribution, how do we define a distribution? We define it by cumulative distribution function, right? So that means the distribution of this. Now, how do we define a distribution of this? Let's say this is defined as x less than x greater than equal to minus x. And of course, let's say this is 0. Let's say we do not know what this is. Let's say this is 0. Let's not draw it. Let's say this. And therefore, the corresponding this is minus x. So what it's saying is that should be the area. The area before this curve is equal to the area after this curve. Okay. And this is equivalent to saying what? So there are two cases. So this is x less than equal to 0, less than equal to 0, right? So what it means is that whatever x you take, and you see that this is also coming from here. That means if this is this inner part gets cancelled because both are equal. So therefore, it turns out that if you take, so from x, you're getting two numbers, right? The negative of, so if x is negative, then of course it's negative. And if x is positive, then x is positive. So therefore, what you get two numbers. One is the absolute value of x, that is we call mod x, and one is minus of mod x, right? This is what you get. And it's saying that if the greater than equal to mod x is less than equal to minus mod x, so whatever the x is, that's what it's saying. So if you draw this, so this is minus mod x, this is 0, this is mod x, whatever is less than equal to this, they're equal. Okay. Now we are going to see the corollary of this idea that is presented here. So one, observe that if x is equal to 0, then it tells you that probability x less than equal to 0 is greater than equal to probability x greater than equal to 0, right? What else? Now let's say this has a derivative, which is true because this is a PDF, then let's take the derivative. So probability x less than equal to x now turns out to be probability. So observe this is nothing but 1 minus probability x less than equal to minus x. Now this is something you can write. It should be less than minus x, but you can write less than equal to, because this is a continuous distribution. For continuous distribution, probability at one point is 0. So therefore you can add the equal to sign. Now take the derivative. So you get f of x is equal to minus, then again you take this, but then you have the chain rule, minus x, this becomes plus. So what it turns out is that the PDF at x, this height is same as this height. So it turns out that it's called symmetric. So it's turning out to be symmetric, right? The height is same as that. So therefore, this is nothing but a definition of symmetric, because this is something you can do double imply. All of them are one-to-one statements. Okay, this implies that by integration you get this, by integration you get, I mean, this is equivalent statement, and this is an equivalent statement, and you go to this. All of them are equivalent statements. So therefore, you get that if the random variable has a PDF, then its symmetricity is meant by this. This is equal to this. If the random variable doesn't have a PDF, then this is the definition of symmetricity. And that's natural because you are sliding x by small amount and still the area is same. So it should be symmetric. So what it's symmetric means, it's symmetric around the mean, and the mean is 0. You can easily understand that. You can also prove the mean is 0 by taking, since x and minus x is the same distribution, you can say that x is equal to expectation of x and expression of minus x should be same, because they're the same distribution. So their expected value, the mean value should be the same. And therefore you get that expectation of x is equal to minus of expectation of x leads to expectation of x is equal to 0. All of you understood this, yes or no? Yeah, absolutely. Everything takes time. Do not try to understand quickly. Nothing happens quickly. Okay, so I'm glad you understood. That's the whole purpose. Take time, understand, but the understanding is so strong you will never forget it in your life.
To book a trial class for your preparation courses of IIT JAM MS, ISIM STAT and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.